and letting folks in now.
It is on YouTube. Hello.
Hello.
It is on YouTube.
Hi, Miss Rosales. How are you?
Hey guys, doing well. I see some of my kiddos. Thank you for joining us, Ryan. STEAM Academy going strong. Our future engineers.
Yes, NASA engineer.
Yes.
Hi, Kayla. Is that Marcus behind you?
Okay, so we're gonna get started. Hi there, and welcome to today's Destination Space Talk for February 4th. I'm Andres Martinez from NASA here in Silicon Valley, just a few miles away from your schools. Today we're going to be talking about perceptions of Mars, its diverse environments, and its potential for hosting past and present life. But before we get into that,
Everyone in the whole classroom.
let me share a little bit about.
Can I go in? I'll go in school. Can I go in?
Yeah, before we get into that, let me share that for the next several weeks, there will be a number of short talks focusing on space exploration, exciting technology, and career paths, showcasing NASA missions, including the Mars Perseverance rover and NASA's return to the moon with Artemis. We're glad you've joined us today and hope to see you again. So let me now introduce today's speaker. Today we have the honor of having with us Dr. David Marais, who is a space scientist in the Exobiology branch at NASA Ames Research Center. Dr. David Marais will conduct a historical tour of our changing perceptions of Mars, its diverse environments, and its potential for hosting past and present life. Dr. David Marais has participated in the planning and operations of the Spirit, Opportunity, and Curiosity rover missions. He also has investigated lunar samples, meteorites, Earth's early geologic record, and microbial ecosystems that descended from our early biosphere. Please join me in welcoming Dr. David Marais. And for today's event, and for every single time, we only have one rule. Everyone needs to keep their microphone muted, okay? So that we can give the courtesy of our incredible guest today an opportunity to share with you some really cool and amazing things. So everybody keep your microphone muted. At the end of this presentation, we're gonna have a question and answer session where we're going to give you permission to type a bunch of your questions, and then we're gonna make a best attempt to answer as many as we can, okay? So Dr. David Marais, please, you may now share your presentation and begin.
Okay, do you see it now full screen without
Yes.
any? Okay, good, great. Well, hello everybody. I'm showing you a picture that looks like something you might see if you went to a desert someplace, but actually you're looking at Mars. And, you know, for those of us who remember the early days of the space program, having a view like this is just absolutely amazing. And what I'll try to do is to tell you sort of the long history of our thoughts about Mars and what we were able to see there, just to give a little bit of an understanding about just how recent so much of exciting science really has been. The focus here, of course, is, you know, what's Mars like there? What's the environment like? And is there any possibility that it could be hosting life or ever had life in the past? So this has turned out to be a very exciting objective, and it's led to a lot of great discoveries. Now, if I can go to the next slide, there we go. So, you know, why Mars? Okay, if you, there's the big sun there at the left, and this is just a cartoon showing all the planets shown as far, you know, from their distance out from the sun to way out there at Uranus and Neptune and Pluto, way out in the outer solar system. But if you look down in the lower part of this illustration, you can see I've got Venus, Earth, and Mars all sort of circled there. And when we try to think about how could life live someplace else, we try to think about what a solar system needs to provide to make a planet a nice place to live. And of course, as we know, Earth has turned out to be very good. It's got the right distance from the sun, it seems. It's got the right size, and it's got water, of course, which is so important. But the two planets on either side of Earth, namely Venus and Mars, they seem like they could be good candidates. But we've learned a lot more about these planets, and it has really led to the conclusion that beyond the Earth, Mars is maybe the more interesting, promising place to have sustained life, especially up towards the present day. So Mars really stands out amongst the other planets as our most promising destination to learn if life ever existed someplace else. And so there's really two aspects of it. You know, is Mars habitable today, or was it ever possible to be inhabited in the past? And so in a way, we're not only taking a journey through space as we explore Mars, we're taking a journey back in time to see what it might have been like. And every time. Okay, so this is part of our little historical tour, and we're going to start in the year 1911. What? That's like 109 years ago, to sort of start out with what our perceptions were about Mars at that time. If you look in the center of the diagram of the picture here, there's two sort of ovals that show some weird kinds of features. These were features that astronomers back in the 19th century, and that's even before 1900, thought they saw on Mars. And it was an Italian astronomer, Schiaparelli, who mapped these, and he referred to them as canale, which in Italian really means just long linear features. But this fellow, Percival Lowell, thought, you know, sort of interpreted that as that maybe Schiaparelli was talking about canals like in Venice, you know, things with water in them. And because of the shapes that Schiaparelli was drawing, Lowell thought, well, maybe there's a civilization there that is moving water around, just like we have in California, where we move water from the Sierras down to the agricultural fields in the Central Valley and to the Bay Area. So Lowell started really observing Mars with this telescope you see to the right, a very capable telescope, which was really the best telescope at the time for looking at Mars. And he claims he saw changes in these canals from one time to another time. And so for him, that was like sort of a life detection thing. If these are canals, and if they change over time, there must be life there, must be some kind of civilization that's building canals. And that's what this big New York Times article was all about back in 1911. Martians build 2 immense canals in 2 years. Exciting. I should say that back at that time, it was really a beautiful time for viewing Mars. Mars was relatively close to the Earth, and he had this great telescope. And so we think that a lot of what he was seeing at that time was in part due to he had excellent observations opportunity at Mars. But anyway, this was the perception back then. People were prepared to accept that there was a civilization there, that they were building these enormous canals, and he thought that maybe that was because Mars was dry out and they were getting more desperate to move water from where they could find it to where they could use it in agriculture. So he got everybody really excited about that. Okay, so that's 1911. You can see up on the right there. I'm trying to keep you up to date here on the date that we're talking about. Let's now move to another date. And this one is actually sort of, it's on both sides of 1911, but interestingly, I've got 1938 up there. H.G. Wells in 1898 wrote this novel about Mars, and he talked about these wonderful civilizations that were there. And again, you see these canal type features, sort of trying to mimic at that time what Schiaparelli, the Italian astronomer, saw in the 1800s. But you can see now it's been adapted to show these fantastical structures. And the amazing thing is that Orson Welles, who was really just an entertainer, in 1938 did a radio show on the invasion of Mars. And it was meant to be just sort of an entertaining show that people listened to during the Depression. But he made it sound very dramatic. And most people, a lot of people who were listening to the radio actually thought that the Martians were invading us now. And it generated an enormous excitement and concern and almost riots back in 1938. So 1938, just think about that. That's only, 82 years ago. And yet people still were really prepared to believe that we had civilizations on Mars. So that's not that long ago. Okay, let us go now to the next time step. And every time I have to advance the slide, I have to use my pointer. There we go. Okay, now we're moving up to 1955. Well, in the 1940s and the early 50s, the telescopes got a lot better. They were much, much better than the ones that Percival Lowell had. And the key thing that the telescopes found out in that time period was that the atmosphere of Mars was a lot thinner than we thought, a much lower pressure, sort of the pressure you might experience if you went way up in an airplane, like flying across the country or something. But of course, when you're in an airplane, it's pressurized and it's made very nice for people. But outside that airplane, the pressure's pretty low and we wouldn't be able to breathe. And this is sort of the pressures that we were beginning to think was going on Mars. So Chesley Bonestell, the artist name you see in the upper left, was very famous for doing artwork about the planets. And so this was one he did about Mars. And you can see now, we don't see the civilizations anymore. We see sort of this greenish stuff in that linear feature in the center of the slide there. And so he was thinking, oh my, the atmosphere is really thin. We probably don't have civilizations, but they've discovered ice caps, which is why you see the ice in the foreground. And, he thinks that maybe there's still life there, but now he's just using algae. That's what that green is. He said, well, pressure's too low for humans and intelligent life forms. I'll put some algae. But you'll notice he's still got the canals there. He still has the canals that were made famous by the astronomy of the early 1900s. So this is 1955, right? We're on the eve of the space age, and we still have these kinds of features being depicted in popular press. Okay, now let's jump to 1965. And this was the year that when NASA was, these are the time now when NASA was actually beginning to send small probes in the outer solar system. And Mariner 4 was a famous one because it actually did a flyby of Mars. So what you're seeing here is an image of the surface of Mars where you can actually see craters there. And I refer to this time period and this mission as sort of the low point in our concept about whether Mars could ever have supported life. This looks just like the surface of the moon. In fact, when we were planning the lunar missions at that time, with the Apollo program, and of course there were a lot of mapping done of the surface of the moon to figure out where we might land, and those pictures of the moon look just like this Mariner 4 picture of Mars, and so we thought, oh man, this place is no better off than the moon. Pretty depressing to think about how that could ever have supported life, or certainly supporting life today. So this is sort of the low point in our thinking about Mars. And again, just look at the time, 1965, that's 55 years ago. This was our perception of Mars. Okay, so with that, let's move to 1976. So we're really closing in on today here now. That's just 44 years ago. We did actually land on the surface of Mars with the Viking mission. And it looks a little better than what that Mariner picture showed. But what we found out with this mission was that it's a very harsh environment. It's very, very, very dry. In fact, the dryness of Mars is really the biggest problem for life. The atmosphere was indeed very thin. It's only like less than 1% the atmosphere of the Earth at the surface. And so the radiation from space was very severe. And there are things in the soil that could probably destroy any life that would be there, any single-celled organisms, because they would be destroyed by this thing called the soil oxidant. So there was indeed an attempt to detect evidence of life at that time. But the conclusion from that was that the things we saw could be just attributed to chemistry, to chemical reactions and stuff that had nothing to do with life. So that's 1976. And so the message here was that, boy, life at the surface today would be challenging. But also another message that emerged was that if we're going to find any evidence that there ever was life, we have to be a lot more careful in the places that we pick to land. This turns out in retrospect to be one of the worst places you'd want to look on Mars for any evidence of life. But that was where we were in 1976. Okay, so with that, let me just summarize what we knew about Mars at that time. Some of the stuff we knew well before 1976, but a lot of what's on here we now can attribute to that mission. First of all, obviously, Mars is a lot smaller than the Earth. It's probably only about 10% of the mass of the Earth, the weight or whatever. Of course, it's further out from the sun than the Earth. And as a result of that, a year on Mars takes 686 days. So it takes a lot longer for 1 year on Mars because it's further out. It takes longer to go around the sun. Mars is smaller, therefore the gravity is much lower than the Earth, 38%. So you could probably jump 6 or 8 feet in the air and come back down again without hurting yourself because the gravity is just not as great. It's further out, so therefore the sunlight is lower. It's probably a little less than half of the sunlight that the Earth gets. But then the big difference is the atmosphere. As I said before, it's a very thin atmosphere. You would not be able to breathe there, and even if the gases that were there were like oxygen, which we need, that would be a problem because the gas that's most abundant on Mars is carbon dioxide, the kind of stuff that makes your soft drinks bubble when you drink them. It's a very important gas for life, but it's not one that we can breathe to get energy. There are some interesting similarities, though, and that is that the tilt of Mars, when it spins, Mars is at a little bit of a tilt, and it's very similar to that of the Earth, which means Mars has seasons, just like the Earth does. And so it has a summer, a fall, a winter, and a spring, just like the Earth does, colder and warmer, and then back again. And the other thing is that the Mars rotates at about the same speed rate as the Earth, which means a day on Mars is not that different from a day on the Earth. To be exact, it's 24 hours and 40 minutes, a little slower than the Earth, of course, at 24 hours. So these are the things that we've learned now up to about 1996 or so, coming into the 21st century. Okay, so that's a little bit of a tutorial there. Now, this shows a very exciting discovery that Viking mission made. Again, that's 1976, and also it followed up on on observations that the Mariner missions have made. The exciting thing here is that despite what I've just told you, that the environment today is very harsh at the surface and it's very, very, very dry. When we look at the surface of Mars from the orbit, from orbiters going around, just like we have satellites going around the Earth, we see evidence that there were water channels. In the upper left, you see enormous channels that went for tens of hundreds of miles across the surface of Mars, flowing down from the southern highlands into the northern lowlands. If you look at the picture on the lower right, you see little stream channels that come together to form bigger channels and keep going and flowing downhill to form even bigger channels. And so these look for all the world, in this case Mars, that there was precipitation. Somehow you had something like rainfall or snowfall that was, delivering water to the surface, and then the water was running off, just like we think about on the Earth. So even though today it's not possible for water to exist on Mars, it's just too dry. Sometime in the past, there was water on the surface of Mars. And we actually saw this as far back as, the 1970s, which gave us a lot of excitement that, maybe Viking didn't find anything, but maybe that's just because we didn't go to the right place on Mars. And so this notion that if we can just find the right places to go, maybe we can get more exciting results about whether there ever was life on Mars. Here's now a picture from that 1996 mission showing sort of Mars today, as in contrast to what I showed you at the beginning of the talk from the 19th century astronomer and from Dr. Percival Lowell, claiming to have canals on Mars. We're still debating what those features were that he was seeing. And you can see in the lower right here on Mars, there is a long channel, a long sort of like Grand Canyon type feature that might have been one of the straight lines that Lowell was seeing. But what you do see here is you see the ice at the poles of Mars, and you see clouds, actually. Those whitish areas represent clouds that are forming around some of the big mountains that are on Mars. So this is a much more accurate view now of Mars. But then that's the exciting thing about, well, that's Mars today, but what was Mars potentially like in the past? Here is now a map of Mars, and this is something that we've constructed. And it's, if you took the surface of Mars and laid it flat on a flat surface like what we see here, it's what we call a Mercator projection. For those of you in school, you might have seen a map of the Earth or something where you're just projecting all the continents and the oceans on a flat map. But what we're showing here with the colors is elevation. The reddish areas that you see are the high elevation areas. Orange is a little bit lower, green is a little bit lower still, and the blue that you see represent the lowest areas on Mars. And so we have the southern highlands. The high ground is in the southern part of the Mars surface. And on the north, in the northern oceans, we have the lowlands. Also, you see a big crater, which is in the lower right there in deep blue color. That's the deepest place on Mars. And that was caused by a large impact that blew open this big hole in the southern highlands of Mars. But what's interesting here is you see all of these craters, all these little circles represent places where meteorites hit and created a big crater at some time in the past. And what this is telling us is that this southern highlands area is very old. It's been there as a crust, as a stable place for billions of years, because we now know from studying the moon that there was a lot more cratering coming in early in the history of our solar system billions of years ago than what we have today. You could not make this surface today, which is fortunate for us. We wouldn't want to be hit by the kinds of objects that form these big craters on the Earth. That would not make Earth a happy place. So the southern highlands of Mars are very, very, very old. Okay. And the northern highlands are smoother because they've had things like lava flows covering it over since the early days of Mars. So southern highlands, northern lowlands, and now we'll get into a little more detail about other things that we've seen. So here is now, again, comparing the Viking mission 1976 to the 1996 Mars Global Surveyor Orbiter mission. We're looking at the same place, but taken by the different orbiters. Back in 1976 on the left, and on the right, we're looking at 1996. What's interesting about this is that on the left, the images were not as good. We didn't have the ability to tell what the elevations were very accurately. Whereas on the right, the colors are sort of showing you what the elevations are, again, with the reddish colors being higher and the blue colors being lower. The key point here is that all those little squiggly lines that you see in the image on the right are stream channels. And they are telling us that there really was precipitation. There really was water falling on the surface and draining out and forming streams and bigger streams and rivers on ancient Mars. On the left side, we just didn't have it. The pictures just weren't good enough to be able to make that observation. So just by having better imagery in the later mission, we're suddenly getting more excited about what that earlier environment of Mars must have been like. And that represented a key contribution from those orbiters. So this gave rise to the grand plan that NASA came up for exploring Mars from about 2001 up until just very much close to today. And the idea was to have orbiters, as you see in the upper left, each one getting a bit better than the other and doing more types of things than the previous ones, mapping the surface of Mars, just what's down there, what really is the best place to put down a lander. So these orbiters gave us a lot better idea about where to land on Mars. You remember I said that for Viking, we really, you didn't land at the best place. Well, now with these orbiters, we can do that. And we're going to follow this water thing. Where was the water most abundant? Where was it maybe most available to life if there ever was? And that was a big objective from 2001 up until about 15 years ago, 10 or 15 years ago. But now we can determine the safe place to put down the rovers and also places that could be exciting for looking for evidence of life. So as you go to the right there, you can see this notion of habitable environments. Where is the best place we could go to find an environment that might have supported life? And then, of course, the bottom line is, can we then see evidence of life? And so orbiters finding the best place for the landers and then the landers going to those places has been a key strategy of our Mars exploration program. Here is, again, I'm showing you that Mercator map projection, but now I've got little features all over that. And in every little blue squiggle that you see there is a representation of a river system, like I'm showing in the upper left there. And every little round circle with red on it and white in the middle is representing a crater that had a lake in it. So now with these better observations, we suddenly realize that there's all these streams everywhere on Mars that you see the squiggles and all these lakes, all these little white circles with the red rims on them. Those had water in them at some time. So water was everywhere at this time, way in the past. And it means that water was falling from the sky. Now, we still don't know if that was rain or whether it was snow. Most people think it was snow. But this really was a major revelation for us that, there were a lot of places that could have been habitable. And with that, we now sort of reconstruct this idea that on early Mars, we had the sunlight, we had an atmosphere that had to be thicker in order to support this water, and that we had surface water. And so I'm comparing on these two figures what early Earth was like and what early Mars was like. And there were a lot of things that were very similar. So suddenly now, early Mars becomes a very exciting place to explore. And that really has become a focus of our rover missions in recent years. Now, this is sort of an interesting diagram. If you see in the upper left and the upper right, maybe even in the lower left, these smiley faces that you see inside of craters. And, this is sort of entertaining. People have proposed seeing features like this, that there might be intelligent life on Mars. They still think there might be intelligent civilizations that can make these features. They found another place that looked like a bunch of city streets with buildings and all this. But on the lower right, this is a crater in Hawaii, someplace that it looks like a smiley face, but that's molten rock down there. That's lava that's erupted into this crater. But my gosh, you've got two eyes and a mouth. The point is, if you look at enough features, you're going to find something that you think looks like something that people made, like a smiley face or some of the other things, heart-shaped things. The point is that when you're looking at thousands of objects, you're always going to find something that reminds you of a feature that a person would have made or a civilization would have made. But here in the lower right, clearly that's something that a lava eruption has made. And so we have to be very careful if you find interesting things that are just only one or two things across a big place like Mars. It's not necessarily evidence that it was made by a civilization or by life. So that's a sort of a cautionary thing there. But anyway, what our exploration has led to is a series of landers, as you see there: Spirit and Opportunity, Curiosity, and the InSight mission. And I'll just talk very briefly about each in the time that remains. Spirit landed in what we thought, as you can see in the lower part there, a crater lake that had a big stream flowing into it, as you can see there. And what we found there was not so much the evidence of a lake, but we actually found evidence of environments like a sort of a Yellowstone National Park, which actually can support microorganisms. And we haven't discovered the microorganisms, but we have discovered here that there might have been an environment in early Mars that, like Yellowstone, could have supported single-celled microorganisms, such as we can see in places like Yellowstone National Park or in Lassen Volcanic National Park in California. So that was one sort of top-level observation by Spirit. If we go to Opportunity rover, which was also launched in the early 2000s, drove for a long time. It drove for like 26 miles or more. And in this picture, you can see the tracks going back out in the distance. The little arrows are pointing at the trails. It explored a lot of ground there and actually found evidence that we did have lakes on Mars, that we did have lakes at the surface. The wind was blowing the water around, making little ripples in the sands. And again, it was another confirmation that we really did have standing water at the surface of Mars way back, probably 3.5 billion years ago, a long time ago. And then more recently, we have the Curiosity rover mission, is shown here, looking, there's the rover in the lower right, and then in the big picture there is looking straight down at what's called Gale Crater. And again, more evidence that we had a standing body of water in there. And that picture I showed you in my very first slide was actually taken in Gale Crater as we were climbing the mountain in the upper left side there. Okay, so that's very exciting. In this mission, we really were able to document that this lake could have been inhabited by life as we know it. The water was nice and fresh. It wasn't too acidic or and it seems like the lake lasted for a long time, which was another key thing that we really wanted to establish. So these rovers have really paid off. And every time we do one of these rover missions, we get better at targeting places. And so this upcoming mission, the Perseverance mission that now is just going to land in just a few days, is going to get another crater that had a lake. And you'll be hearing about that more in the future. Okay, so I think we are. And then finally, I should probably wrap it up here, but the InSight mission, which is another lander that came down, actually has discovered Marsquakes. In other words, we're now understanding what the inside of Mars is doing, and it's just giving us more insight, literally, into what the early environment of Mars would have been like, because activity deep within a planet is very important for sustaining evidence of, or sustaining habitable environments at the surface. So the question is, did we have life on early Mars? We have now discovered that the life could have been supported 3-4 billion years ago on Mars, but the question still remains, did life occur there? And this is going to be the objectives of the Perseverance mission, is to get there, bring the best samples back, and really see if we can find evidence of life. And of course, ultimately, this paves the way for potential human exploration on Mars at some time in the future. And that, folks, is where you come in. That future is your future. And you get to sort of decide, or if and when and whatever, humans will be eventually walking on the surface of Mars. That is it. And thank you very much. So are we good for, do we have time for questions?
Thank you, Marais. We're gonna go ahead and open it up now for questions. We'll spend a few minutes answering as many as we can. Let's see, Danielle, are you with us?
Yes, I am. Can everybody hear me?
Yes, yes, we can hear you.
Okay.
Yes, yes.
So the first question that we're going to go ahead and ask is, how long are these rovers going to stay on Mars, and are other rovers still there?
Those are great questions. And the answer is we don't know. I mean, the point is that these rovers are living a lot longer than we ever thought they would. When we first landed with Spirit and Opportunity back in the 2004, we thought that if we were lucky, each of the rovers might last as long as 6 months. Well, Spirit lasted for 8 years, and Opportunity lasted for, 14 years. So they lasted a lot longer than we thought. Curiosity rover landed in 2012, and we thought that that mission might be good for 5 years because it has a type of power supply that can last pretty long. Well, it's still going, okay? And so it's probably good for another 4 or 5 years. So they last a lot longer. The answer, I guess, to your question is that they will last as long as they can survive. We will not abandon these rovers. If they're still there and making observations, we're going to keep going. But the good news is that they're lasting a lot longer than we'd really had planned them to.
Okay.
And then what was the other question? Yeah, so Curiosity rover still active today. The other two, Spirit and Opportunity, are no longer active. They finally broke. Okay.
Okay. Okay. Remember the rule. Everybody keep their microphone muted. Okay. Just answer your question in the chat.
Don't forget, if you guys would like to ask questions, please type them into the chat, okay? So for our next question, someone would like to know, how are the rock or minerals that are collected by the rovers analyzed? Is that done on the rover itself?
Okay, good questions. They're analyzed, or they're selected because we think they're the most promising samples of a habitable environment, an environment where life could live. And so this crater that we're going to, called Jezero Crater, used to have a lake in it, just like Gale Crater did, and the other crater I mentioned. And so we know by looking at lakes on the Earth what the kinds of sediments are, the sand and the silt and the mud and everything that are usually have a lot of microorganisms in them. So sort of based on our experience on the Earth looking for evidence of microorganisms in a lake, we're looking for the same kinds of deposits as we would sample on a lake on the Earth to find evidence of the microbes. The rover has to identify and confirm that, yes, these are the most promising samples. So the rover isn't necessarily going to do life detection, but it's going to pick the samples which we think, for a number of reasons, are the most promising for harboring some fossils or some kind of evidence of life that might have lived there in the past. And so we have cameras, we have instruments that can say something about what the rock is made out of, and to try and identify enough things about the rock to say, this looks awfully similar to a kind of sample I would take if I were exploring a lake for evidence of life on the Earth.
Okay, we have a couple of other really interesting questions. Someone wants to know, can we live on a different planet? And also, piggybacking off of that, will we ever be able to live on Mars? Because that is eventually part of NASA's long-term goals, is settlement on Mars.
Okay, so can we live on another planet? I'll give you the answer in two parts. If we just went to another planet that we know of right now, we couldn't live. And I think I mentioned a little bit when I was talking about Mars that the atmosphere is too thin. It's made up mostly of carbon dioxide, and you just, we can't live there if we have to breathe that atmosphere. But just like there's places on the Earth where you couldn't live if you didn't build a house or somehow didn't provide things, we have to provide something for us if we're going to live on Mars. So the second answer is yes, we could live on Mars, but we have to bring our own house. And of course, we have to bring a super house. We have to bring a house that has allows us to put an atmosphere, the air inside that house that we can breathe. So we need basically to put like a station there with a very hard outside surface that keeps our gas, our precious oxygen inside. This is a whole area of work at NASA, and that is life support for humans outside the Earth. And of course, you already know examples of that. We have our space station. You see these guys floating around in the space station and they're talking to you and everything. That spacecraft is pretty much a container that holds in the air, allows the temperatures to be nice, and maintains the astronauts. We basically have to deliver or build something like that on Mars in order for us to be able to live on Mars. So just like we have a space station that we can live inside of orbiting the Earth, we have to build some kind of a structure that does the same kinds of things to support us on Mars. And this is a very active area of research, and it very much is required for humans to live on Mars.
All right. Well, thank you, Dr. Dave Marais. Everyone, can you help me give Dr. David Marais a virtual round of applause, please? Did you guys enjoy the talk? I did. Come on, let's give him a round of applause. Yay.
Thank you.
Thank you. That was great. Let me just share with you guys that, again, we have other talks scheduled this whole month because we want to celebrate that Perseverance, our Mars 2020 rover, and the Mars helicopter, it's almost there. It's about to arrive at Mars. And so on February 18th, it is going to enter the Mars planet, and it's going to land on the surface. So tomorrow we have another talk. Come and listen to Dr. Fernando Aviera. He's gonna tell you all about Perseverance. And then next week, as you can see, we have other talks too. So the whole month, we're gonna have very interesting and cool presentations. All right, so who's coming back tomorrow?
Great.
Everybody, good. Okay, thank you. This will wrap up our presentation, our activities today. And I want to thank the Elm Rock School District for hosting us. Thank you. It was great. You guys did a great job. Thank you for following a rule. Just one rule. Not too bad, huh? All right. Thank you. Thanks, everybody. Have a great
Thank you.
year. Stay safe.
Bye-bye.